Okay, this is a Tactical Technician series from Diagnation. Today we're going to talk about the Egr Effect. You can see in front of you, you have your schematic, your illustration. We're going to be looking at a few components related to the Egr system on this 2004 Honda Accord. First of all, I want to talk about what an Egr valve is, how important it is. It is a very, very important, effective, ecologically designed emission control component. In other words, it negates oxides of nitrogen which come out the tailpipe, which cause photochemical smog and are detrimental to the air we breathe. Egr works by recirculating exhaust gas back into the intake to lower combustion chamber temperatures and hence reduce the oxides of nitrogen. I can attest to that firsthand. Many years ago I had a car rolling on a dynamometer and under load, and I was looking at a 5-gas analyzer, and I was looking in particular at the NOx, at the parts per million, and it seemed to be pretty low. I took the vacuum hose off the Egr valve and waited about 10 seconds, and I watched the parts per million of NOx go to about 4,000. And for a while, then I put the vacuum hose back in, and then I seen it drop to about south of about 250. So I've seen firsthand that it is a very effective system at reducing oxides of nitrogen. When I talk about in this particular capture here, in this deal, I want to talk about the Egr effect. Not necessarily, we know that when an Egr valve hangs open at idle, we get the rough idle, we get a high position sensor voltage, maybe a chunk of carbon on the valve pintle holding it off its seat, and it would be pretty obvious. And it would most likely code or a situation where there is carbon in the recirculation passageway, where the sensing component that validates Egr would not corroborate with the command, hence you get an Egr code, you get a P0401 or other 400 series codes. I don't want to talk about those today. Today I want to talk about the Egr effect when the Egr is actually commanded on. If the scope has value as far as finding a symptom that maybe you wouldn't see on a scan tool. And I don't want to discredit the scan tools. Scan tools are awesome for their graphing capabilities. They have many Egr related PIDs that can help isolate Egr problems. So basically I just want to look at this is a road test from idle up into the Egr range. The Egr will come and go. You'll see it on the scope. Everything will validate. And I just want to look at various, the inputs and the outputs, everything related to Egr. And I'll explain them on our 8-channel scope. Our channels A, B, C, and D are at the fuel injectors. That's injector 4, 3, 2, and 1. Our purple channel E is at the map sensor, because the map will react instantaneously to Egr. This is a speed density system, and also map will have obviously effect on fuel. Channel F, the gray channel, is going to look at the duty cycle command from the PCM. It is power side switched. We're going to look at that duty cycle from the PCM to the Egr solenoid. Channel H orange, or I'm sorry, channel G orange, we're going to amp clamp the solenoid to see if the solenoid physically moves. That's a good validator, an amp clamp, to know that the solenoid is actually doing work. Channel G burgundy is the position sensor of the Egr valve. That's where the valve is, where the PCM knows where it is by looking at that position. Anyway, I will. The road test has been done. We've got our capture, and we'll go through it and analyze the sequence of idle to about cruise, where the Egr is active, and take a look at different parts of the system. That is a frozen screen. I will. This is the first screen. This is kind of at idle, and just when I'm at the stop sign, ready to take off, and we'll talk about it. Let's take a look at idle for starters. We got our injectors up top. We'll look at those, and then we'll look at other components. These are our injectors right here, and they're open. They're not open too long. I'll get a pulse width just on one of them. We're looking about 3.17 milliseconds on the injectors. Pretty common on a Honda idle. Our purple is our map sensor voltage, and when we look at that, we're going to look down and we're going to see about Usually Hondas like to be south of a volt, and they always, a speed density Honda, I'm going to say we're in the 0.9 range. Okay, 0.98, okay. 0.9, around there. We're just slightly south of a volt, which is good vacuum on a Honda. Our burgundy is our position sensor for our EGR pintle. That's where it is. And I'm going to say, from my experience with Acura Honda, about 1.2 at idle. Well, looks like about 1.5. I'm sorry. I was on the wrong, I was going to, see, I had a little color clash. Okay, we're about 1.15. That is our idle voltage at idle when the valve is not being lifted. That is when it's on its seat. Our gray obviously is our duty cycle, which is not being commanded at idle, which is expected. We don't see it, we see a flat line. Our orange is our current. Obviously there's no current flowing through the EGR solenoid because we are at idle. Let's start to put I put my foot on the throttle. This is kind of what happens. I'll see an initial situation here. We'll kind of key in at the transfer point when we go from idle to some load. Obviously in the gray you can see the duty cycle. You can see the current start to flow in the through the EGR solenoid. We can see our vacuum change right here. By the way, those are vacuum pulls. We won't talk about that. There'll always be plenty of that, you know me. But anyway, that's our map sensor. Our vacuum is elevating because we're coming off idle. And let's try to see where that vacuum is voltage-wise. More color clash. Okay, about 2 volts. Yeah, about 2 volts of vacuum, which is pretty much expected when we come off idle. Let's stretch the current a little bit to see what that looks like. So now we got duty cycle. This is our transfer point. We're gonna go from off idle to EGR. Obviously we're giving it throttle, so we're going to see an increase in pulse width. As you can see as I roll it, there's the EGR. PCM decides to start to activate the EGR, and there is our current, and there is our duty cycle, which is a positive side switch, high to low. Our pintle position on our EGR valve is about, remember it was about 1.2. Right now it's about 1.4. It will climb. Let's go to the next screen. And see where it goes. Now we're into pretty much full-on EGR. I want to get back on that pintle and see where that is. That's the pintle voltage for the EGR, and that's about 1.93. So the valve is lifting. Our duty cycle is going up. Let's kind of zoom in on a segment here. We can see our fuel injectors. Obviously they're open more, and that's expected because we're under some load. The reason I brought up this video is that, you know, does this methodology have an advantage when we're looking for that EGR valve that's given us that hesitation and we're not really sure what it is, and we can't see it on the scan tool, just like a valve that maybe is a little lazy, that's opening a little late, that's opening a little early, that's not closing, that's closing late, and that engine gets that undesirable EGR when it's not really expecting it. Just something to bear in mind. Where the scope would be advantageous in that situation. So we're going to keep moving on. It looks like we hit a spot where we had a little duty cycle change. Here we go. Yeah, we got some duty cycle change here as we move on. Definitely see that. Okay. How's our vacuum? We got clipped because I didn't use a good range. Nonetheless, let's get back to let's keep going down the road and look for a spot where EGR. Yeah, okay. This is what I want to talk about. This is just a dropout, and I created this. This is not a natural vehicle. This is the area I want to key in on as we watch the EGR effect. Does this method is this a good method if we were in a situation like that? Okay, the EGR went away, and obviously when the EGR goes away, the current obviously goes away. Our pintle voltage obviously will lower. That's expected. That goes down to about 1.1, which we expect. Our vacuum starts to tail off. It takes a little while, but let's see it right around here. We can see where our vacuum is. Our vacuum going down to what we expect at idle, maybe even a little on a decel. Okay, we lost some throttle, and our vacuum's about, I don't know, 800 millivolts. Our valve is off. What kind of a pulse width do we have here? Okay, we got a pulse width measurement. I'll measure one injector. Obviously there's less load, I realize that. We're about 2.95 milliseconds on the pulse width. And now we're gonna get back to EGR right here. Obviously things are changing. We got the duty cycle in gray. We got our current flowing through the EGR solenoid. Our pintle position is way high, which we expect. Where's that guy? About 2.62. That valve is really up there, okay? And our vacuum too. I'm gonna, I didn't scale, vacuum, I'm gonna say, I didn't scale it like I wanted to, but that's just the brakes is sometimes doing stuff live or, okay. Okay, there's an idle, there's almost about 2.4, which is almost a full load for a Honda, because they peak out about 2.9. So anyway, let's take a look at our pulse width when we're in kind of full on EGR. We can see our current flowing. Pulse width, again, I'll pick yellow. It seems to be, okay, we're about 9, we're almost 10 milliseconds right there. Now that's because obviously our loads increase, but I'm just wondering if we had a tip-in hesitation, if we saw something odd there because of an EGR, because of a problematic EGR, would it be shown in the injector pulse width? That's just something to ponder as we continue to look at this. There's another situation. We're kind of coming and going on EGR. The current flowing through the solenoid right there in orange, and we take a pretty good drop. The solenoid, the PCM stops commanding EGR. That was just for a brief moment. And obviously we can, that's how long is that moment? How long did EGR go away for? Let's determine that. Camera's still rolling. Wow. Okay, that's 148 milliseconds, a little more than 1/10 of a second. That's a blink of an eye or even less. But then again, our pulse width again is, as you can see, I'll kind of get both in there so you can see. You can definitely see, compare green here to blue here. So they're almost double. So when the EGR goes away, obviously we get less fuel, which is of course expected. But nonetheless, if we did have a problem, would we see it in fuel? So as we continue to roll through the video, EGR coming and going, you can see everything affected. Duty cycle, injection, current, you can see right here as voltage goes up, current goes up because it is positive side switched. We never want to just read the current clamp for sort of validating that our solenoids are actually moving. As we continue to go, then we come up, now we come to a decel, which is pretty much at the end of the run here, and the EGR is going away. It's coming into an idle. We can verify idle by looking at our vacuum. I did not put the throttle position sensor. I would have liked to have done that. You can do that, doesn't? You can just, think about what you want to, the high priority inputs. Yeah, that's a decel. That's a pretty good decel for a Honda. That's like 729 millivolts. So anyway, just keep this in mind. As a method, actually you never want to discount. I would go scan tool first. This hookup is a little bit involved. We got the 4 injectors at the PCM. The current ramp was not too difficult. The EGR valve was pretty accessible. Just pulled the wire sheath back to get through the position sensor and the wire, the feed wire from the PCM, and also current clamp the wire from the PCM. So, and the map sensor too. Anyway. Hope this was, you enjoyed the video. Just bear in mind, think about EGR and think about those problems where, that little hesitation where we're not ready to pull the trigger on an EGR valve. If this is a way we can sort of validate it as to being the problem. Anyway, thanks. Signing off here and all the best.